going to go about solving this jump. Okay. What would be the first thing that you would do? Subtract 4, and then you would probably get to this point where you would have something like this, right? And then you would be like, all right, now I'm going to do probably the circle of life in order to solve. So remember, ln is the same thing as log of base e. Okay, so we could rewrite this as log of base e of x plus 7. This is going to be a mess, right? Because if we did this circle of life, we would have this nonsense, right? Did that help us at all? No, it just created more of a mess. So instead of doing all of this nonsense, what we can do instead is we can plug this into our graphing calculator and plug this into the graphing calculator and look at where it crosses over. Okay, for those of you who are writing down very fast, this is page 15. If we go into Desmos and we type the first equation, and then we type the second equation, where do they cross over? They cross over at -6. And then they also cross over at 2.269. Coming back in here. So they cross over at x equals -6 and x equals 2.269. And all we did was plug these two things into Desmos and look at where it crosses over. Find approximate solutions for f of x equals g of x and understand where those solutions occur. Okay, so they show us a lovely graph of what we just went over. When given a difficult problem, sometimes the easiest way to find solutions is through graphical or table representation. The function on the left-hand side is in the blue, and then the function on the right-hand side is in the green. Okay, really quick, what type of function is this guy on the right-hand side? Polynomial, but what's the more accurate one? We got linear, we got quadratic, we got logs, we got exponential, we got cubic, we've got, am I blanking? Radical, we got rational. Which one of these is x squared? Not exponential. Is the x in the exponent? No. Okay. So we have a power of 2. Quadratic. Okay, so this one in the green is a quadratic. All right, what about this one on the left-hand side? We got ln of x plus 7. That's a log, okay? So that's going to be a log. So what do we notice about these functions? Well, they intersect right here and here. So they intersect at x equals -6 and x equals 2.269. Looking at this table, we can see the left-hand side is graphed up here, and the right-hand side is graphed down here. Okay, what should we notice about the tables of these functions? What should we notice about the tables of the functions? X equals -6 is the same thing as what's over here, right? All right, and then looking at 2.269, which is roughly in between here, right? We could kind of see that these are going to be similar, right? Because 2.269 would fall somewhere in here. But we see from the table exactly that at x equals -6, the y values are the same. Okay, so we're going to use these values, and we're actually going to change this to -6, and we're going to substitute it into the equation. So we're going to plug in 2.27 for x. Everywhere that we saw an x, we're going to write 2.27. So we're going to say log of 2.27 plus 7 plus 4, and we're going to set that equal to 2.27 squared plus 4 times 2.27 minus 8. Somebody plug this side into Desmos, and then somebody else plug this side into Desmos, and we're going to check and see if it's the same on both sides. Calculator, what did you get? You probably got something like 6.227 something. And on the other side, you got 6.23, right? Well, these are both about the same, right? So we can say that x equals 2.27. When we plug in -6 into this equation, and we simplify, so we plug into Desmos, we're going to get 4 equals 4, which are the same on both sides. So we know that x equals -6 and x equals 2.27 are the solutions. So where are the solutions f of x equal g of x found on a graph? So basically, we're given two equations. What do we do first? We're trying to find their solutions. We're given two equations. First, we're going to plug them into Desmos. And next, we're going to see where they cross each other. So where are their intersections? Okay, sometimes they have one solution, sometimes they have more than one. Sometimes they don't cross at all. Sometimes it could be no solution. Okay, but you're going to plug the two equations into Desmos and see where they cross each other.